So we're still talking about being differentiable, having a derivative, and being continuous. And I want to ask the following question of ourselves. Question: is it possible for a function to be continuous at x equals c and not differentiable at x equals c? So to answer this question, we're going to look at a function, an absolute value function, the absolute value of x minus 2, and we're going to graph this function. So this is a translated version of the absolute value function. You move it over to so here's what my function looks like. And is this function continuous at x equals 2? And the answer is yes. This function is continuous at x equals 2. And so now what I want us to look at is the derivative at x equals 2. So let's start with the left hand. The limit as x goes to 2 on the left. Well, if I'm approaching 2, so let's go ahead and plug in limit as x goes to 2 from the left. The absolute value of x minus 2, this is just minus 0 over x minus 2. If I'm approaching from the left over here, then x minus 2 will be negative. And when you take the absolute value of a negative number, it's going to change signs. So here, the limit would be negative 1 times x minus 2 over x minus 2. It's because x minus 2 is negative, so I gotta multiply it by negative 1 to make it positive. And now these x minus 2's cancel, and I'm just looking at the limit of negative 1, which would be negative 1. Now let's look at the limit on the right-hand side. The limit as x goes to 2 from the right. Well, if I'm looking at the right, so let's plug in, this is x minus 2 absolute value minus 0 over x minus 2. If I'm approaching from the right, then x minus 2 would be positive, and so this limit would just be the limit as x goes to 2 from the right of x minus 2 over x minus 2, and those both cancel, so I'm just looking at the limit as x goes to 2 from the right of 1, which is 1. And now, if you compare these two one-sided limits, I got negative 1 and 1. These are not the same or not equal. So because they're not equal, I know that this function f is not differentiable at x equals 2. And so the answer to the question is yes, you can have a function that is continuous but not differentiable. So the answer to our previous question is yes. Let's look at one more problem relating to this idea of continuous and differentiable. Let's look at this example. Let's look at the function x to the 1/3. This function is, if you graph it, you'll see that this function is continuous at x equals 0. And now let's see, is it differentiable? So let's take the limit as x goes to 0. X minus 0. Now let's plug in. You'll get x to the 1/3. F of 0 is just 0. And so if I'm looking here, the limit as x goes to 0, it's 1 over x to the 2/3. Using my exponent rules, you subtract the powers here. 1/3 minus 1, it's negative 2/3, so it's in the denominator here. And then this limit will be infinity. The numerator is constant and the denominator gets smaller, so this limit is going to be infinity. So what does it mean when we get an infinity in our derivative formula? It means that the tangent line is vertical at x equals 0, and that means it's not differentiable at x equals 0.